In this presentation, we are going to explore the raceway, the very start of the blast furnace process. It is a zone in front of Tuyere where preheated air or hot blast enter the furnace. This is where combustion begins, setting the stage for everything that follows in iron making. Here, especially the high blast comes in contact with the coke, forming a sort of a racing zone where coke churning in clockwise motion keep on going, and in the process the blast impact on the coke also generate a fines, which these fines also getting just accumulated beneath in the lower portion of the raceway called bird nest. So coming to our next slide, which will gives us more information subsequently on the raceway. So in the raceway, hot blast burns coke or injected fuel like pulverized coal, natural gas, or oil, or hydrogen, or hydrogen based any fuels like coke oven gas or CBM. So anything. So these create an intense flame with temperature between 2000 and 2300 degrees centigrade. Oxygen in the blast convert to carbon monoxide, forming the primary reduction gas. And this is the core gas which start reducing the iron ore or the ferrous material that is getting charged on the throat of the furnace. So as coke burn, void form, helping the burden descent, and the blast velocity at the tuyere can reach 170 to 250 meter per second before slowing inside the furnace while going and traveling more and more high towards the uptakes. So now, as we know, raceway is the starting point. This is the basically a start point of the combustion, reaction, reducing gases and everything. Thus, this is very vital, and because all function start from this point. So we can say that raceway perform many functions, but out of that, four functions are very important, and one by one we will share these. So it generate the heat. It generate the heat needed to melt the iron ore. It produces carbon monoxide for reduction reaction. It initiate the entire blast furnace process. It manages the fuel buffer, that is coke between the melting zone and tuyere. If fuel injection stops, this buffer can deplete in just we can say something 2 to 3 hours max, risking the thermal collapse. So it is also a good way to see that what's the buffer within the furnace in terms of closure of PCI or auxiliary fuel injection at the tuyere level stops. Now coming to the control of this raceway, because as if it is important, its control is also important. And to control raceway performance, we monitor the RAFT, that is called raceway adiabatic flame temperature. So the adiabatic flame temperature, which rises with the hot blast temperature and oxygen enrichment, because oxygen is deprived of nitrogen. So once we inject oxygen, our flame temperature stop increasing, and hot blast temperature has got a lot of sensible heat, so it helps in raising the flame temperature, but drops with moisture and fuel injection. And as we know that fuel when the moisture or any fuel which is subjected to a ambient condition injection, at that time this flame temperature drops. And the next control is about raceway is to your velocity, which is one of the very important aspects. So idle range is 200 to 20, especially in European context, whereas in the Koreans and all those, they used to keep around more than this. So but when we handle this to your velocity onto a higher end, it also has got a lot of impact and damages to the core. So too low prevents gas from reaching the center. So we have seen that too high and too low, both aspects are indicating towards a abnormality. So we need to choose some moderate one which serve the both purpose. Fuel injection, about the fuel injection and the raceway control is that fuel injection must be consistent. If it's stopped, then we need to reduce oxygen as quickly as possible, so that if we keep on going oxygen enrichment, then we start forming the metal deprived of that shortfall PCI injection, which stops. So this result in processing of colder iron, and our it will cool down our hearth. So once our injection stops, then first and foremost thing is to stop oxygen, so that we can reduce the formation of hot metal which are deprived of this injection fuel. So coke blanks also can help to restore heat quickly, but it will land to the tuyere level at a much later stage. So we need to reduce the blast. Reduction of oxygens are the very good way to take care of such circumstances. Now, circumferential symmetry is also very important. Balance injection and wind distribution are essential in this regard. So uneven injection or block tuyers causes asymmetric melting and very erratic production. And once it has got a erratic asymmetric melting or erratic production, our thermal stability is not there. Furnace undergoes a lot of sleep and pressure rise and fall, chemistry fluctuation, a lot of disturbance. So now coming to our raceway monitoring, in the similar topic, in the similar slide, we will say that operators must monitor raceway health very closely, and as far the tuyere health is concerned, we need to see that whether it's burning or tipping in a very timely fashion, because this can cause a water leak and severe damages to our carbon brick also. Coming to the scab, we should see that unreduced material dropping in front of tuyere signals poor burden distribution or fine segregation. It can address uh, by our observation the tuyere peep side in terms of a dull light. So a dull glow from the peep side may indicate water near tuyere many times, and it also indicate many times the unprepared materials passing in terms of these unprepared materials are in terms of this spill, that is mm, mm, peeling of the walls and other unprepared sort of action like slips or cold fines materials which are travel very vertical. So these all are the indication that we can see from the dull glow of the peep side. So this also helps in mitigating the colder condition and the asymmetric condition, disturbances in the process upset in the blast furnace. So now question arises, then what is the optimal condition? So for optimal condition we need to aim for high hot blast temperature, high coal injection, and low blast moisture to minimize hot metal costs and to meet steel plant demands.